Je vais faire l'introduction rapide de Klaus Schilling et puis Khalifa va arriver un petit peu après ça. Donc aujourd'hui, on a la chance d'accueillir Klaus Schilling, qui est professeur et titulaire de la chaire de robotique et télématique à l'université de Würzburg en Allemagne. Et c'est le président de la compagnie Centre de télématique, qui fait de la recherche à un niveau industriel et travaille sur des projets de satellites. Donc aujourd'hui, Klaus va nous parler du développement des missions satellites Tim et Tom, pour lesquelles ils sont en train pour l'observation de la Terre et pour lesquelles ils cherchent des partenaires pour exploiter leurs données. Fait que sans plus tarder, je vais laisser la parole à Klaus. Et Klaus, you can go whenever you want.
Yeah, bonsoir, good evening, and I will talk about small satellites today. So you see what it's like. These are the satellites we have in orbit, and currently we are preparing about 30 of them for launch into orbit. We have already some in orbit, and I will discuss in particular about Earth observation satellites, and in particular opportunities offered by the international cooperation within the regional leadership context. So I hope you can see my slides.
Yep, we can see it.
The story started actually some years ago in 2016 when this regional leadership summit happened in Munich. And they initiated the project on small satellites for Earth observation. Here, all the partner regions, Quebec, the region Quebec, Bavaria, Georgia, Upper Austria, São Paulo in Brazil, Shandong in China, and Cape Town in South Africa, decided to join in to cooperate on educational aspects as well as on projects. And one of the approved research projects was related to small satellites. So here we have two components. TIM is the Telematics International Mission, while TOM is the Bavarian contribution towards TIM. These are 3 satellites financed by the Prime Minister of Bavaria in this international cooperation. But you see, also industrials are participating, and yeah, so it's an interesting team which is contributing here, and in particular Quebec with different universities participated. Tim has the objective to do photogrammetric observation of 3-dimensional surface features with 3 satellites. So you see the different perspectives the 3 satellites offer towards the same observation target. And from this we can reconstruct by photogrammetric methods related 3D features. The 3 satellites are in the final stage and will be launched end of the year 2022. So the next steps, which is now of interest for geosciences, is to take advantage of the data coming in the next years. So we will operate a ground station network with partner institutions, and Polytechnique de Montréal is part of it. So they have a ground station antenna to receive all the downlinked data. And of course, data are not the end product. Data have to be processed to information by people in geoinformatics. Yeah, so we count on you that interesting information will be gathered and converted from the data obtained. Yeah, so the satellites generate a continuous flow of data And application fields envisaged are a primary target, ash clouds from volcano eruptions. And you see it directly on this image. You might remember we had a huge problem 10 years ago when this Icelandic volcano erupted. In Europe, all the flights were grounded. So all aircrafts were forbidden to transfer because of the ash clouds moving from Iceland over Europe. And the height of the ash cloud was very difficult to be monitored. So cloud height measurements are a big topic, but also monitoring of lightnings from space, the monitoring of fires and floods, of soil moisture, but also maritime applications. Yeah, we can observe with the satellites ships on sea, and ships who have not ignited their automatic identification, the so-called AIS, they are candidates for pirates. And so illegal fishing, coast monitoring are topics for the maritime applications. And of course, also environmental warning is a big issue in case of earthquakes, in case of other floodings and things like this. So the satellites provide interesting photogrammetric data, but they need to be processed to get the information about the end products you see on this list. So therefore, we are opening up now for a user community in geosciences throughout all the partner countries. Yeah, and in particular, Quebec is a key in this context. So we are not only doing this Tom and Tim mission, but to give you an overview about ZFT, our key product are miniature 3-axis attitude control systems. So we can point our satellites very accurately. And this allows us to jointly observe with the 3 satellites in the Tom mission the same target area. We have practiced this already in orbit. So the 4 satellites of NetSat were launched in September 2020, and they practiced networked control. It was a pure technology demonstration mission, but the features we need in Tom were practiced already there. And we have another Earth observation mission called Cloud CT, where 10 satellites cooperate to do computed tomography to sketch the interior of clouds, in particular the ingredients in the clouds. And computed tomography, like used in medicine, provides the key to characterize the interior. Yeah, and in particular, water content is a major input for climate predictions. So that's a mission to be launched next year. And also here, interesting user communities line up to take advantage of the data. In 2024, we will have 6 satellites launched for biomonitoring purposes. So on board of the a little bit larger satellites, we have multispectral cameras, and we fly in very low Earth orbits, very close to the Earth, in altitudes about 400 kilometers. And from here, as we are close to the Earth, we get very good resolution. Yes, this will be our second very low Earth orbiting satellite mission. We have a communication mission called LOLASat, which will be earlier in 2023. Yeah, and to test this appropriately on Earth and to manufacture such quantities of satellites, we have robotic installations to do human-machine collaboration for efficient satellite integration. We have also future Earth observation networks planned in the next step, where higher altitude orbit satellites and low Earth orbit satellites cooperate in Earth observation. To test them before launch, we have a multi-satellite test environment here in Würzburg, where we can cross-check the attitude control systems, the orbit control systems, to enable formations in orbit. And formations mean the satellite self-organize in orbit by exchanging data via inter-satellite links. So they are in orbit orienting towards joint objectives. This is in contrast to what is done usually in constellations, where many satellites receive from ground control prescribed data. Yeah, they get target data and they cannot be adapted. Here we adapt on site during the observation to the observation target.
Klaus?
Yeah?
Yeah, excuse me to interrupt, but we still see like your first slide of the PowerPoint.
Oh,
I think maybe like
that's not good.
there was a mixed with the full screen.
Sorry. So I try to return. So you still see this?
We were just seeing like the regular PowerPoint window,
Yeah.
not the
You
full
see
screen.
the PowerPoint.
Yeah.
Possibly I use this mode, that I increase it. Sometimes it doesn't properly transport. So I do the preview smaller and increase here. Is this now well visible?
You would need to share your screen again.
Oh, good, I return. No, it's a pity if you only see the first slide. Now you see it?
Yeah, we see your PowerPoint here.
Maybe you do it a little bit smaller so that you see the full size.
Yeah, that's good.
Yeah?
Yeah.
And then I progress here on the... So you see here the different introduction slide with the model of the real satellite. And in particular, this with you see also the bottom with the invitation to participate and to contribute.
Yep.
Okay. Fine. Then here you see the overview of the different missions. Yeah, I sketched which are in preparation, form networks in orbit. And in the next slide, I show you the overview what we do in the Center for Telematics. So we have a space section where we have emphasis on new space, on small satellites, satellite formations. And we also address, in addition to Earth observation, also secure communication. So we have quantum technology to do appropriate encoding of quantum keys, which are distributed from the satellites. We have also an automation department where we do robotics industry 4.0. And we also have a mobile robots department where autonomous driving, sensor technology, three-dimensional cognitive systems are the key. Here we are organized as a non-profit association, and one of the satellites I already mentioned is NetSat. Here, 4 satellites were launched into orbit to demonstrate the formation flying technology. The satellites are built in a modular way. So you see the different satellite subsystems here on top. And like Lego building blocks, you assemble the satellite very quickly, step by step. So it's a very fast integration we can do with our satellites. And you see the images obtained. So one of the overview images taken in orbit from the NetSat satellites. And these were the basis for future missions. So quantum key distribution missions use the cooperation between the satellites, the high pointing accuracy we can achieve, in the same way as here in TOM, the photogrammetric observations. So instrumental are the attitude control systems doing such precision pointing also at the dimensions of small satellites. Yeah, and this is also for Cloud CT, the computer tomography mission of clouds, a very key aspect, but also for future telecommunication missions. Yeah, the satellites we build use experimentally first different technologies. Like you see here, our board computer. And here we used radiation shielding by software. We have a hot redundant complete system. So the microprocessors, the storage chips are all available in a redundant way. And if deviations are detected by fault detection, identification, and recovery software, then the switch is done to the healthy system. This was practiced in orbit, and it was running for 6.5 years without any interruption, despite all the space radiation environment effects like single event upsets or ledge ups occurred. Single event upsets occur every week. But you didn't see an interruption because it was running continuously, switching from the one system to the other system when necessary. So 6.5 years, it's, even for big satellites, hardly achievable. Here you see the miniature attitude control system. So the core is a motor, and you have a rotational mass here on the left, and then everything is sealed. And the reaction wheel has just a dimension of 2 centimeters. So this reaction wheel is 2 centimeters. You see it in comparison with a 10-cent coin. And this way we can place also in hot redundancy 6 reaction wheels to cover all the 3 axes of the attitude. Yeah, and it's also a very low power consumption. So at just half a watt, we can run the attitude control system, which is quite neat. Yeah, and so different building blocks, like you recognize the board computer, also the telecommunication system, the batteries of the power. Everything is plugged in a base plate. And so in a very modular and flexible way, you can assemble satellites very efficiently. So this approach was a winner of the Airbus Challenge 2017 related to satellite production systems. And also the whole satellite we do in a standardized way. You know the CubeSats, the 10 by 10 by 10 unit satellites. These are the smallest one, and we produce satellites up to 20 by 20 by 40. So that's a mass of about 20 kilograms. So we are specialized in the small satellites, and we try to squeeze everything into these small dimensions. And so far, most functionalities could be addressed at such small dimensions. Yeah, here you see the satellite integration. So human-robot cooperation to assemble the parts and pieces. One specific example here are the solar arrays. So the robot places very accurately the solar arrays on the side panel. And yeah, as the glue of such solar cells is very poisonous, the collaborators are very happy that the robot is doing the job, and only at the end they retrieve the finished panels and place them for shipment. Now coming to TIM, as already mentioned, the main scientific aim is photogrammetric observation of ash clouds with a small satellite formation. And secondary objectives are all the other mentioned topics like disaster, environmental monitoring, ship detection, and so on. The regular leadership summit means that our states want to collaborate, and they support such collaboration by student exchanges in the same way as by technology projects like in TIM. And here we observe, yeah, we did already pre-tests. So we used ash clouds taken from images from space station by the astronauts to recover the 3D features. So here a volcano eruption was imaged by the astronauts on board the ISS, and due to the motion of the space station in orbit, we use the different perspectives to retrieve already 3-dimensional images. So basic software of this is already established. And we hope now that as we can do now images at the same moment of time, all the parallax problems from using the motion of one observer will disappear this way. So we expect better quality because we can do at the same instant of time image of the same area, and then we can transfer it by S-band transmitters, and the camera I will address in a moment in more detail. So here we use an image sensor from Sony, which provides high resolution. So it's more than 2000 by 2000 pixels per image. And this means we have a ground resolution of about 20 meters with a swath width of about 50 kilometers. So this way we can get enough resolution for volcano eruption observation. 20 meters are quite enough. But for other features, possibly you would like higher resolution. But that's what we can provide right now. By sensor data fusion from the 3 different cameras, we expect that this ground resolution will be further increased. Yeah, that's the resolution of one camera. But also post-processing, yeah, will improve how much we will experiment in orbit. We have not only one camera, but also here redundant pairs of cameras on each satellite. So also this redundancy can be used for sensor data fusion to improve the resolution. So there are plenty of opportunities for research to take advantage of the redundancy, to take advantage of the 3 satellites observing the same target from different perspectives. You see here the radio modems. So we have different radio modems on board. And the TOM timeline will address that we finish the flight parts next month in May, or maybe also in June. Then we transfer the flight models to the launch site, and end of the year, possibly with launcher delays, we don't know, possibly it's also begin of 23. But currently the launch is scheduled for end of 22. Yeah, and then you will get related observation data. With our turntables, we did already related tests. So you see a model of the volcano, and a robot, a mobile robot, is simulating the motion, the orbit motion. The turntables are used for the attitude pointing, and we use visual servoing algorithms. You see on the bottom at left and right to do by visual servoing more accurate tracking of the volcano area. So different partners have different contributions. In INPE, this is a Brazilian space agency which participates. They contribute the ground station networks to download this huge amount of data. They support also testing, assembly integration and testing. They also consider to contribute their existing or future satellites to this network. In Quebec, so far, the Polytechnic Montreal is adding their ground station to the network. This means we can send data, control data to our satellites. And in particular, we can download data direct in Canada, which they can then further distribute, by example, to Sherbrooke. The next ground station is in Stellenbosch. Also here they participate with the ground station network, as well as the University of Georgia in Athens, Georgia. Yeah, the Chinese here in particular CSAT, that's a Space Micro Instrumentation Institute, they built in parallel additional three unit CubeSats that they will be launched later after Tom. Tom is now the first of these satellites in this RLS context. They also add their ground station to the network. So you see, it's in the technology, it was an interesting combination of different capabilities at different technology sites in the partner regions. The ground stations are really interesting to increase the amount of data which can be downloaded. And we have a central server, and yeah, the individual control of the station remains in the hand of the partner, but all are devoted to the joint objective to receive the payload data in the most suitable way. So you see here, these ground stations are well distributed across the world, and this means this is increasing, this is multiplying the amount of data which can be downloaded. Yeah, so that's currently a coordination activity. And if you have ground stations in Sherbrooke, of course, it's welcome that you complement our friends in Montreal. You see here our two ground stations we have in Würzburg. So we have one ground station, Yagi antennas at the university side, and another ground station with higher pointing accuracy at the Center for Telematics. So all the data received are located in a repository which can be accessed by the scientists. So coming back to Tim, in particular, we want to collaborate with geosciences, yeah, to take advantage of the data. And yeah, we are looking forward to your ideas. The raw data will be deposited in a repository, and there will be access by password protection. But for all interested partners in the different partner regions, access will be provided. And the only request we have is that you acknowledge the RLS mechanism of international cooperation. Yeah, but you can get access to the data free of charge to do your kind of processing in your institution. And we mentioned already the different fields where we can imagine how this three-dimensional data can be further used. Yeah, so all data will be stored in a server, and then we offer them to the international RLS community. And similar like done earlier for the volcano eruption processing, I think also in the other fields, data can be converted in relevant information. And so it's my final slide. I repeat again, we would like to invite you to participate, to take advantage of this facility and be part of this geosciences user network, which will take advantage of this data. And with this last slide, I'm open now for your questions. Thanks for your attention, and we can now discuss what might be appropriate for you, what kind of thesis work might be possible, what kind of, even of student exchanges can contribute to this RLS mechanism.
Thank you very much, Klaus, for your presentation.
Yeah, my pleasure.
It was very, very interesting. Est-ce qu'on a des questions? J'ai vu qu'il y avait des pouces qui s'étaient levés. Et que si jamais on a des questions, c'est le moment.
Non, vous pouvez parler en français, c'est bien, but I will respond in English.
Ouais, moi j'aurais des questions là.
Vas-y, Khalifa.
For the first, the previous satellite, NetSat.
Yeah.
I'm wondering the cameras inside the satellite. Are there multispectral cameras or just only one band? What are the characteristics? What were the characteristics of these cameras?
Yeah. No, the cameras were just a side effect. The main objective was technology demonstration on formation flying.
Okay.
And just to prove that the cameras really, or to prove that the satellite really works.
Okay.
We just for fun placed some low-cost cameras. So these are just some webcams.
Okay. Just to try.
Just to show it's working.
Okay.
Because otherwise it's really difficult, yeah? So we tried also to catch some of the companion satellites, but they are too far apart.
Okay.
So now but the cameras are a crucial point. So we have a resolution of 20 meters by Tom. Here the cameras are really a core payload. And higher resolution will be achieved in future missions, like for QB. You saw the 6 satellites to be launched in 2024. They will have multispectral cameras, and they will have a resolution of 4 meters.
That's really interesting, yeah.
Yeah, but that's the future.
Okay.
So we try to improve step by step.
For the new satellite, Tom and team,
yeah.
Do you have any idea about the vertical precision for example, because it will give, these are photogrammetric data.
Yeah.
So we'll have the third dimension.
Yeah, right.
What is the expected accuracy for this third dimension?
That's part of the experiment. It's difficult to predict, yeah? So there are some expectations, but we would like to prove it in orbit.
Oh, yeah, okay,
yeah.
I see. Okay.
No, it's with sensor data fusion processing. you can improve the pure resolution a lot.
Yeah.
Taking advantage that you really have 3 images. So it's the magic of processing software.
Yeah,
And
absolutely.
in particular, if you take a look what the images from Ukraine, it's surprising what they can achieve with just with software, with post-processing.
Yeah.
So
Yeah.
Maxa only uses general available pictures. And it's not really impressive resolution with the raw data.
Yeah.
What they achieve and publish in newspapers. Yeah, that's impressive.
Yeah. And
So
also
we do similar things also here.
Yeah. And also, if I understand very well, the 2 satellites will give a global coverage of the Earth.
Yeah, right.
Okay.
No, what is intended is that the user community can specify target areas.
Okay.
Yeah, and if you send it to us, we try to make pictures of the target area you specified.
Okay. I
Yeah.
see.
So that's something we need to establish, and we are open to the demand of the user community. So we have an interactive system where you can specify. Of course, we have to do a fair sharing of observation time, but it's just limited to the partner states. Yeah, so
Yeah.
I think you have good opportunities to specify your targets and to really get the observation data you need.
Great. And we don't have an antenna at Sherbrooke for data acquisition, but at Ottawa, the Canadian Center of Remote Sensing has an antenna. I don't know if you had some collaboration with them.
No, but RLS is open to all the scientists in the member states.
Okay.
And as Quebec is member states, that's, yeah. Everybody can take advantage of this.
Yeah. I know. So also for us, the application side could be very interesting. Application to land monitoring, to disaster, and so on.
Yeah.
And we will see at in our research center how we can collaborate. And I'm quite sure that we will be part of the project.
No, would
At least
be
we
very
can
nice.
contribute. We can contribute to the calibration and validation on for the application side.
Yeah.
And develop different algorithms to extract information from this type of data. This could be very interesting.
No, great.
Okay.
Also here in geosciences, we have scientists from Bavaria, from Cape Town. So I think this will be also a very interesting mixture where you can exchange in the international way experiences.
And also the exchange of students could be a good way for us. I'm quite sure that some of our students will be interested to participate and to go into different areas. That could be also a way of collaboration.
Yes, indeed.
Yeah.
Here between Bavaria and Quebec, we have a especially well-developed mechanism.
Yes. Yes.
Mm-hmm.
Okay. Thank you very much for this nice presentation.
My pleasure.
Est-ce que d'autres personnes ont des questions? Oui, Charles?
Hello. Thank you very much for the nice presentation. It's very interesting subject. I was just wondering for the launch of 2024, do you think there will be a possibility to add another camera sensor?
Can be discussed. It for Tom, it's impossible. Yeah, the satellite is finished. But for future missions, we can discuss what payload might be helpful, and we always have to convince the sponsors. Yeah, so these are all paid satellite missions, and usually accommodation of payload is possible, but the people want a sharing of costs typically. Yeah, but this is something we have to discuss, and if in the final stage there's empty space available, of course additional things can be added.
Thank you very much. It answers my question. Thank you.
But what might be really interesting is Canada is also member of ESA. Yeah, Canada surprisingly is member of the European Space Agency.
Yes, exactly.
And this means we can propose to ESA, by example, joint projects.
Yes.
The payload can come from your side, the satellite can come from our side, and ESA is paying for the whole mission.
Yes. Okay. I'm asking because we already have a project with ESA, and it's concerning light pollution measurements.
I see.
And so this could be interesting for the time of observation where there's not a lot of sunlight. So maybe this could be a great addition to the project in these cases.
Yeah. I think ESA as well as Bavarian Quebec Corporation might be funding mechanisms, which is important for space. Yeah,
Totally.
Space is really expensive. So, but here are opportunities, I think.
Great. Thank you very much.
Est-ce qu'on a d'autres questions dans les gens qui sont en ligne? Okay, I would have like two quick questions before we wrap it up. The first one would be, so you expect to launch Tom late 2022 or 2023. What would be the delay, for example, between the launch and the availability of the data? Do you need like to make some more calibration, or as soon as the satellites are online, like the data is available?
No, I think for launch and early orbit operations, we only would have 1 or 2 weeks.
Oh, only? Okay.
Yeah, no, it's quick. And when the data are collected on a routine basis, I think they should be quickly offered. So you can access the data in the repository maybe 1 hour after they were taken.
Okay.
So this should be all automatized, and so quick data provision is one of the objectives.
All right. And I had like another question. So you said on the Tom satellites, basically the spatial resolution would be about 20 meters for now, with a footprint of about like 50 kilometers. Yeah. What would be like the expected revisit time, like to fly over same point over time? Would be like 5 days apart, 2 weeks apart, 3 days apart?
The orbit will be in 600 kilometer altitude, and we are on a sun-synchronous orbit. So it's not this repeat cycle is not really exactly specified.
Okay.
Yeah. So we had to look for an inexpensive launch. What we achieved was sun-synchronous and right orbit altitude. But it's not a dedicated launch for us. Yeah, so we will learn this later, what will be repeat cycles.
Okay. Good.
The approach is rather the other way around. We want to place as many satellites as possible, and they should complement with their data. So whenever you move over the same target area, you take an image and you update them.
Yeah. Okay.
In the classical way, you are completely right. You specify Earth and Sun synchronous orbits. Here we were only able to assure Sun synchronous orbit.
Okay, yeah.
Yeah, so we have the same illumination of the surface spot, but we might get a repeat cycle, but we are not sure.
All right. And just out of curiosity, like, what's the cost of such a mission for three satellites like that?
We altogether so far it was about 3.5 million.
Okay.
Which was donated by the Bavarian government. Yeah, so to rebuild, it would be lower cost now.
Yeah.
But so the costs for the small satellites vary. The lowest satellite we provided was around 300,000 euros. The highest single satellite was around 4 million.
Okay.
So it depends very much what capabilities you want. What pointing accuracies do you need? These are the cost drivers.
Okay.
Do you need a propulsion system? Or in case of a single satellite, you often do not have a propulsion system. You just drift wherever you go and you image the ground. When you fly in formation, you need a propulsion system to keep the satellites together, so that they are not drifting apart. You need a precision attitude control to orient the satellites towards the same observation point. Yeah? So the functionalities you need determine the cost range.
Yeah.
Maybe one specific interest for you is you went to Antarctica. We also in Bavaria, we have geoscientists which are interested in Arctic exploration. So maybe this way also new connections can be established.
Yeah, that's for sure. Yeah. All right, thank you very much. I think, Khalifa, do you have something to add, or?
No, I don't have any other question. The talk was very interesting, and I think we can find a way to collaborate in this project, for sure.
Yeah, great. So I'm looking forward to the next meeting.
Yes.
Nicolas has my email and the other contact data. And we're looking forward to the collaboration.
Yes, me too.
Yeah.
All right, thank you very much, Klaus.
Thank you very much.
Et merci à tous d'avoir assisté à cette présentation.
Ok, merci.
Merci bien. Au revoir.
Merci beaucoup. Bye, à la prochaine.
À la prochaine.
Bye.
Merci, au revoir.